Example 3. The population of a small town is increasing at a rate of 4% per year. If there are currently about 6,000 residents, about how many residents will there be in 5 years at this growth rate? Okay, once again, let's begin with our generic exponential equation of y is equal to a multiplied by b raised to the amount of times it has occurred. Let's substitute in our known values. The town's initial number of residents is 6,000. We are also given that b, which is equal to 1 plus r, because we are dealing with growth here. We are increasing the population by 4%, so it's 1 plus r. If we are decreasing the population, it would be 1 minus r. So b is equal to 1 plus 4%, so 0.04, which is equal to 1.04. And the amount of times it has occurred is equivalent to 5. Let's substitute these values in. So we really have y is equal to a 1 plus r raised to the amount of times it has occurred. So we have our final population would be y equals 6,000 multiplied by 1.04 to the 5th power. This is roughly equivalent to 6,000 multiplied by 1.21665, which is approximately 7,300. So the town's final population, after increasing at 4% for 5 years, would roughly be 7,300 residents. Let's confirm the population after 5 years is 7,300 people. Let's create our table. We have population over here on the right. And on the left, we have after the amount of times this has occurred, which is in years. So at 0 years, to begin with, we would have 6,000 multiplied by 1.04, because we're increasing by 4%. And we are going to raise that to the 0 power, because we're talking about times 0. 1.04 raised to the 0 power is 1. So we are left with 6,000 multiplied by 1, which is 6,000. After 1 year, we would have 6,000 multiplied by 1.04 to the 1st power, which is equivalent to 6,290 residents. At year 2, we would have 6,000 multiplied by 1.04 squared. In other words, we have 6,000 times our 1.04, which is at 1 year, and then multiplying that by 1.04 again for the 2nd year, resulting in 6,489.6. Year 3, you'd have 6,000 multiplied by 1.04 to the 3rd power. So we have 6,000 multiplied by 1.04, multiplied by 1.04, multiplied by 1.04. So this is equivalent to 6,749.184. At year 4, we would be taking year 3 population and multiplying it by 1.04. So we'd have 6,000 multiplied by 1.04 raised to the 4th power, which is year 3 of 6,000 multiplied by 1.04, multiplied by 1.04, multiplied by 1.04, and then multiplied by 1.04 for the 4th year, which is equal to 7,019.15136. At year 5, we would have years 4 population multiplied by 1.04. So it's 6,000 multiplied by 1.04 to the 5th power, which is equivalent to 6,000 multiplied by 1.04, multiplied by 1.04, multiplied by 1.04, multiplied by 1.04. That would be for 4 years, and then multiplied by 1.04 for the 5th year, which is equivalent to 7,299.91, which approximates to 7,300 residents. Example 4. You want to reduce the size of a picture to place in a small frame. You aren't sure what size to choose on the photocopier, so you decide to reduce the picture by 15% each time you scan it until you get it to the size you want. If the picture was 10 inches long at the start, how long is it after 3 scans? So let's think about this. Let's begin with our generic exponential equation of y is equal to a multiply b to the amount of times it has occurred. Let's substitute in our known values. The initial size of the picture, a, is equal to 10 inches. We are dealing with decay, so b is equal to 1 minus our 15%. In other words, we still have 85% of the picture size after each round. And the amount of times this has occurred is equivalent to 3 scans. Let's substitute these values in. Y equals a multiplied by 1 minus r raised to the amount of times it has occurred. So y is equal to 10 multiplied by the difference of 1 minus 0.15 raised to the 3rd power. This simplifies to 10 multiplied by 0.85 raised to the 3rd power, which simplifies to y is equal to approximately 10 multiplied by 0.614125, which is approximately 6.14. So the final size of the picture that began with a length of 10 inches long, after 3 scans and decreasing it by 15% would be 6.14 inches. Let's confirm this answer by creating a table. So on the left-hand side, let's put the number of times it has occurred. So number of times that it has been reduced. And on the right-hand side, let's go ahead and put down the size. So to begin with, after it has occurred 0 times, would be our initial amount of 10, because 10 multiplied by 0.85. Remember, it's 0.85 because we are decreasing by 15%. So our base here is going to be 1 minus 0.15. So b is equal to 0.85. So we'd have 10 multiplied by 0.85 to the 0 power, which is just equivalent to 10, because 0.85 raised to the 0 is 1. Okay, after it has been reduced 1 time, we would have 10 multiplied by 0.85 raised to the 1st power, which is equivalent to 8.5. After this has occurred twice, we've had 2 reductions. We would have 10 multiplied by 0.85 raised to the 2nd power. It's occurred twice. This is equivalent to the first reduction of 10 multiplied by 0.85 and then multiplying that again by 0.85, which is equivalent to 7.225 inches. After this has occurred 3 times, we would take our value of 10 multiplied by 0.85 raised to the 3rd power, which is equal to the second time it was reduced multiplied by 0.85 again, which is equivalent to 6.14125, which is approximately 6.14 inches.